Okay, this says to factor the quotient. Well, that quotient was x squared minus 1, and that is the difference of squares. Just like x squared minus 16 would be x plus 4 and x minus 4, this is going to be x plus 1 and x minus 1. That's an old trick from Algebra 1, and you saw it again in Algebra 2. So look, the x to the fourth can be written as the original x minus 1 that I started the notes off with, and then the x minus 2, that was my second long division part, and now these two factored to become x plus 1 and x minus 1. There are four linear factors, x times x times x times x equaling x to the fourth. That's the process. That whole thing is the process. We're going to use division to find out if we can get factor by factor, and then we try to make it smaller and smaller by using the quotient and dividing the quotient to make that a smaller degree to the point where we get all linear factors. Okay? Now long division, it works with divisors that have any degree. The next trick, synthetic division, it only works with a divisor that has a degree of 1, so I mean linear divisors. So there's a reason we got to hold on to long division. Let me go back one page. If the thing that I knew wasn't a linear factor, but if I knew x squared minus 1, for example, was a factor, I would have to put x squared minus 1 here and do long division. Synthetic division would not be an option. Okay? So if you remember long division and synthetic division and you're thinking, why don't we just always use synthetic division? It's so much easier. That's why. This only works with linear divisors. Okay, here are my Larson directions for how to use synthetic division. You ready for this craziness? Build a top house. Of course, you build a top house. And then you write every coefficient from every term of the dividend, including a 0 if there are empty terms or missing terms, in a horizontal line. So you build a house and you write coefficients in a horizontal line, and don't forget zeros if you're missing terms. Leave room for another row of numbers underneath the coefficients, then draw a line under the imaginary row underneath your row of coefficients. Then you build a bottom house underneath at the end of that line, and you put the 0 for the divisor. Well, find the 0 for the divisor, and then put it in the top house. You drop the first coefficient under the line, and then here's what you do. You multiply, you put, and you add. That's the process of synthetic division. You multiply, you put, and you add. You repeat number 8 until there is a number that you finally got in the bottom house. The number of the bottom house is, of course, the remainder. If it's 0, you just use an actual x-intercept. The numbers below the line are the coefficients. I don't think I spelled that right. I think there's another I in there somewhere. Are the coefficients for what we call a depressed polynomial. Okay, which is the quotient. The reason we call it a depressed polynomial is because the degree of the quotient is always 1 less than the dividend. We're dividing by a linear factor, and when you divide by a linear factor, the quotient will have 1 less x to it. So we call it the depressed polynomial. So look, I'm going to use synthetic division to do this. This was the first problem I did today. The first problem I did, x to the fourth minus 3x to the third. Let me go back, and there's a 3x and a minus 2. I'm pretty sure it's the first problem that I did today. Look how much long division took us to get to this remainder equals 0. Okay, we had to do all this work on the side. There's long division. Now I'm going to do that work again. What I'm going to do in this tiny little space with synthetic division, it goes like this. You build a house, number 1. You write every coefficient. There's a 1 for x to the fourth, a negative 3 for x to the third, a 1 for x squared, a 3 for the x term, and a negative 2 for the constant term. You leave room for another row of numbers, and you write a line underneath the imaginary row of numbers. You build a bottom house underneath the line at the end of the row. You find the 0 for this factor, x equals 1, and you put it in the top house. Then here's number 8. I'm at number 8. I'm at number 7. You drop the first coefficient under the line. So the first one just drops, kind of like we do in long division. Then you multiply, you put, and you add. 1 times 1 is 1, so I multiply, I put, and then I add. Negative 3 plus 1 is negative 2. And I keep going. Multiply, put, and add. 1 times negative 2 is negative 2. Negative 2 plus 1 is negative 1. Then you multiply. You get negative 1, you put it there, and you add. You get 2. You multiply, you get a 2, you put it there, you add, you get a 0. Hey, look at that. We got a remainder of 0. Now, let me go back to the front page, and let's look at what the quotient was. It was 1x to the third minus 2x squared minus 1 plus 2. 1, negative 2, negative 1, 2. 1, negative 2, negative 1, and 2. 1, negative 2, negative 1, and 2. So by doing this division, we just found out that this could be written as x minus 1 times, lower that to x to the third, and we have 1 x to the third minus 2x squared minus x plus 2. And it would be plus 0, but I don't need it because you don't have to write plus 0. Synthetic division is quick, but it only works with linear divisors. Next page.